Hey guys, today I want to teach you how to use systems of equations in specific situations. So make that your next title and then clear those distractions and get that brain ready for something new and unpause when you're ready to go. So speaking of systems of equations, we have been dealing with ones like this. And the main way we have been solving them now is to make their graph and to find this point where they intersect. That intersecting ordered pair should make both equations true. Just to double check, if you go to that first one, negative 3x plus 2, if this is the solution, x and y, if x equals 1, y should equal negative 1. Can make sure that they do. Negative 3 times 1 is negative 3 plus 2 is negative 1. That's true. And should work for the second one as well. If x equals 1, y should equal negative 1. Is that true? 2 times 1 is 2, minus 3 is negative 1. It is. So that one ordered pair is true for both equations, and that's the solution. So we're going to move on today to like situations in context where like a real thing is going on, so to speak. So rather than just a y equals equation, we're going to look at situations that are real like this. Andre and Noah started tracking their savings at the same time. Andre, Noah. Andre started with $15 and deposits $5 per week. Got some language in there I recognize. Starts with. That sounds to me like an initial value or a y-intercept. That's how much he starts with before any time has passed. So an initial value of 15. That's going to be my y-intercept on that graph. And deposits $5 per week. Per is unit rate language. And unit rate tells me slope or rate of change in a linear equation. So it sounds like I'm going to have a slope of 5. Noah started with, that sounds like an initial value, 250. And deposits $750 per week. We got cut off there. That sounds like a slope, unit rate. So this is a very common situation in systems of equations, right? We have two people. Andre starts with more, but increases slower. Noah starts with less, increases faster. Where do they have the same amount, or when does the person who started with less end up with more? That's kind of where we end up. So what they're going to be doing, they're going to be depositing money each week. This was a week per week. Yeah, there it is. Couldn't find it. So remember, whenever you have a unit of time, I always recommend putting that on the x-axis. So weeks down here. Week 1, week 2, week 3, week 4, week 5, 6, 7, 8, 9, 10. I'm not going to go by ones on my money axis here. I need to pick a good unit. These make it tricky with the decimals, don't they? One thing I'll notice here, 250 times 2 is 5. 750 times 2 is 15. So I think if I go by fives, I'll always be halfway in between when I get to a 50. That's okay. I don't feel too bad about halves, but any other like partial unit gets tough. So I think I'm going to go by fives. I'm afraid I'm going to run out of room still, but I'm going to try. I think these numbers are going to get high pretty fast. I'm afraid I'm going to run out of. I'm afraid $50 is not going to be enough. It's about as high as it's going to get. Well, we'll see. Maybe I'll have good fortune here. So let's start with Andre. Andre has an initial value of 15. He's going to start there after 0 weeks. He already has $15, and he's going to go up $5 each week. So one more week, $5 more. One more week, $5 more. One more week, $5 more. So his line's going to look about like that. And I'll switch to Noah in green. So Noah starts with 250. That's halfway to 5. and he increases $7.50 per week. So $7.50, that is 5, so 1 unit up plus another halfway to 10. So each time I'm going to go 1 more week, I'm going to go up 1.5 units. So from here, 250, 750 more would be 10. So he's going to go up to 10. Next. 1 more week, 750 more. So that's 1.5 units right there. Oh, I'm going to make it. I thought it would have to go higher before they intersected. 1 more week, 1.5 more units. 1 more week, 1.5 more units. 1 more week, 1.5 more units. There's my solution already. I'm going to keep going so I don't look like I just stopped early. And we're going to get a graph that looks about like that. So a few things I can tell from the graph. One, here is the solution to the system. That point right there, which is 5 weeks and $40, that is the solution to the system of equations. What that tells me is, in context, after 5 weeks, they both have $40. They both have the same amount of money after 5 weeks. That's what the solution tells me. That's the point at which they're the same. The other thing you can kind of tell is before that time, before they get here, the green line is lower than the red line. So before 5 weeks, who's green? Noah? Noah. So before 5 weeks, Noah has less and Andre has more. Noah has less. After 5 weeks, now Noah's line passes Andre's line. So after 5 weeks, I guess the same one, Noah has more. So that's what I can read from a system of equations graph. When you have a real situation, that's kind of what you know. There's usually a point where somebody starts with less, but they do something faster, and there's a point at which they cross, and then after that, the person who saves more each week passes the person who started with more. That's how they usually end up looking. Let's do one together. This one is another fee one like this. So if you would go ahead and pause and copy this down, you'll need some graph paper to make your graph. You cannot make that, so leave that where it was. And we'll figure this out. So you'll notice kind of the same thing happens here. This is very common in systems of equations 1, right? This person has no starting fee, which is nice, but more money per month. This person has a starting fee, but they pay a lower per month. That's very, very common in situations like this. So remember, we're going to graph how many months and their cost. And if you have a unit of time, I always suggest putting that on the x-axis. Always makes things easier. So 1 month, 2 months, 3 months, 4 months, 5 months, 6, 7, 8, 9, and so on. All right, next thing I have to do is pick my unit going up on the cost. This is always tricky because I don't want to end up in the middle, awkward middle of boxes any more than I have to. I don't mind being right on a line. I don't mind being halfway, but I do mind anything else. I don't want to be like a third of the way up and have to guess where that is, or anything like that. So when I look here, Anna, before I even make that, let's look at the situation more carefully here. So Anna, no registration fee, that's an initial value, a starting amount. So initial value is 0. And per month, that is unit rate language. So that's my slope. So the slope's going to be 25. So that means each time 1 month goes by, up 25. Got to keep that in mind so I don't end up too awkwardly in the middle of stuff. Other person here, Ravi's Club, has a one-time registration fee of $40. So initial 40. Charges $10 per month less than Anna's Club. So hers was 25. So this one, the slope or the rate of change is only going to be 15. So I've got a lot of 5s. and a 40. So I'm probably safest going by either 5s would be great. The problem with 5s is I'm only going to get up to about 50. And Ravi starts at 40. That's probably not going to be enough on my graph paper. If you have more space to go up higher, you'll be fine. I probably don't, so I probably need to go by 10s. Oops, which I didn't do right already. 10, 20. This may still not be enough, but I said that on the last one and I was wrong, right? I keep wanting to go by 5s. This still may not be enough, actually, when I think about it. We'll see. So I'm going to go by 10s. So 5, 25, 15, I am going to have to go to halfways. That's okay. I don't mind doing halves. I do mind doing any other part. That's why I chose 10s. So let's do Anna in red. So Anna starts at 0, and each month increases by 25. So one more month, $25 more. One more month, $25 more. One more month, $25 more. Month, $25 more. I hope they meet before $100. If they don't, I'm going to run out of room. So there's Anna's graph in red. Whoops. Always hard for me with this digital pen to actually hit the... Remember, do this with a straight edge too, when you can, because these solutions can be hard to see. All right, I'm going to switch and do Ravi in green. Ravi starts at 40, slope of 15. So one more month, $15 more for Ravi. One more month, $15. One more month, $15. One more month, 15. So close. After 3 months, they're only $5 apart that they've spent. One more month. No, one more month. 50. Oh, look at that. I hit it right on the nose. It's going to be right there. And so as I extend, there's my solution. Boy, did I luck out. So some things to note on your graph after you've made it. First of all, this point right here where they intersect, that is the solution. So what that solution means is after 4 months, both have spent $100. So that's what that point tells me. The solution is the magic month or point in which both of their plans cost the same amount of money. Other things to note, you can kind of tell before that point here, the person who's red, before that point, Anna spent less because her graph, her cost is below Ravi's. And then after that point, Ravi has spent less. And a lot of times you have to make decisions based on situations like that. Is it better to get the thing that starts cheaper and then costs more per month? Or is it better to get the thing that starts with more price and then increases by less? So that's what situations look like with systems of equations, and that's how you can kind of interpret what their solutions mean. Hope this made all the sense to the world to y'all. And if you need to give this another go, please do, and we'll finish this up tomorrow. See you then.